Hello, my name is Rob Nettles Miller. For my project, I decided to do interpolation of out-of-plane forces on a 2D plane. So a little background, I work for a startup called Next Input. We have a MEMS-based force sensor that we're trying to use to replace capacitive and other mechanical switches in consumer devices. One of the things we're trying to do more of is trying to use fewer sensors and get more press areas. So if you can imagine a 12-button ATM keypad, if we could get away with 6 sensors instead of 12, but still have 12 pressable areas, that's half the cost, and it's very attractive to the consumer. Problem is, 2D planes have very complex mechanics, usually requiring finite element analysis or something equal to do it, but they are reliable and very nonlinear, which to me sounded like a very good machine learning project. This is highlighting where the sensors are on this keypad. My data acquisition was I used an automated CNC machine to get our data. Basically, the only pre-processing I had to do was baselining these raw analog to digital converter values so they were started at 0, and then discretizing all the XY coordinates into different zones. I just actually used 2 different approaches, 2 different models. For the force side, I used linear regression with some nonlinear terms added in. And for position, I used a neural network with a 3x4 grid of zones to try to get good performance. Linear regression I chose because the weight output is a very continuous function, and I wanted something that could work even if I pressed harder than the inputs I had tested for. So I had to experiment a lot to figure out what it is, because like I said, there's no textbooks that'll tell you how a 2D plane will react to a point force. So here's my results. Even though some of these, like the cubic values and multiplying each term, had better or lower costs, when I actually tried them in a live setting, if I ever pressed harder than about 1,000 kilograms, suddenly the measured weight would plummet, and it was really bad. So even though raised to the 3/2 was inaccurate, not quite as accurate most of the time, it extrapolated very well, so I decided to choose that. The neural network, I ended up using tan-H as my activation function, L2 regularization for the regularization terms. This was all just so I could use some libraries that would speed up my work. I ended up with 3 hidden layers, size 15, 16, 14, and that was found just pure through iteration and experimentation to try to maximize my accuracy. Here's showing off how I came to these conclusions. There was very little difference between 3 and 4 layers, and I was worried about the risk of overfitting, so I went with the smallest number of layers I could. The results were actually very good. So the final cost for force was about 12,000, which doesn't sound great, but that means I'm about plus or minus 100 grams, and that's good enough for my use. I actually chose to discretize in my Python code this value before it's displayed to the user, so they can't even really tell there's some inaccuracy in there. And also, it performed very well even if you press hard. For position, the final accuracy from my testing data was over 98%. And then again, in my Python code, it worked very well, except in the corners, it's a bit iffy. I think that might require mechanical redesign. We'll see. Here is a demo I took at work with a very simple GUI I made in Python. So as you can see, it actually surprisingly works pretty well. I was very happy with this result. Now hopefully you can see that as my finger is flexing and pressing harder, that it does match up on the screen. Ideally, we'd have some kind of haptic feedback as well as visual. But yeah, overall, this was pretty great. There's a couple of things we'd like to do in the future with this project. Adding dead zones between each press zone is important for users to sort of mean that a press like in between 2 buttons won't be registered as one or the other. It'll be registered properly as not a press. So that would mean making the press zone smaller and adding a dead zone. To do this, I'd have to get more data tighter than a 16 by 24 grid and use different tip types and all these sorts of things. And in the future, I'd also like to try multi-touch, which very, very nonlinear, very complex, but I'd like to see if a neural network could properly capture accurate.